How do you size a StormBlaster rotary jet cleaner system so that it effectively cleans a storm tank? Now, StormBlaster rotary jet cleaners can clean an amazing range of size and shapes of storm water attenuation tanks. The units themselves come with a variety of nozzle sizes, resulting in different jet lengths and flow rates. They can operate at different pressures, and we often install multiple units into tanks to clean larger tanks. Now, over the years, we've developed some specific protocols for designing these systems to clean almost any storm tank you can imagine. There's a few limiting factors on some types of tanks that we can't clean. I've covered those in another video. So what are the basic factors to consider here in this kind of system design? Well, first one is jet length. Each of the StormBlasters will be operating at a certain fluid pressure and will have a certain nozzle size on it, and that will dictate its effective cleaning jet length. And ideally, we want to position the tank cleaner at the top of the tank, but centrally ideally. And this means that more of the tank is within range of that jet length. What we want to do is each part of the tank that tank cleaner is responsible for cleaning, we want to have it well within the range of that jet length. So we just simply measure from the point of the nozzle to the furthest point that it's going to clean. Make sure that distance is within the range that we specified, and therefore anything that's under that range is going to be cleaned as well. Now, it might not be possible to get optimal positioning, particularly on open tanks, but we'll talk about positioning in a minute. Okay, the second consideration is overall water usage. Now, each cleaning head will have a cleaning cycle. Each rotary jet cleaner will have a cleaning cycle, and it will have a flow rate depending on what pressure you're running it at. So it must run through its complete cleaning cycle to reach every part of the tank. So if you multiply the cleaning cycle time by the flow rate, you're going to get an overall water usage per cleaning head. Now, it might be tempting to reduce this as much as possible, and that's certainly what we try to do. We try and reduce the amount of water, but there is a design criteria that we develop. You need a certain amount of water overall per meter squared of the tank floor. And we've developed a protocol to specify this. So yes, we want to reduce it down, but there's a limit on that. And the reason for this is we need to have a certain amount of water moving around within the system to allow it to drain effectively. So over the years, we've developed some protocols and formula to work this out. So we need to have a minimum amount of water usage as well. The third factor to consider is, we mentioned this before, pumps and pressure. In an ideal world, we want to have all the jet cleaners operating at around 8 to 10 bar fluid pressure. This increases the overall flow rate through the nozzles if we were running them at a lower pressure, but it also speeds up the cycle time. So they complete their cleaning cycle quicker at 8 bar than they would say at 4 bar. And when you multiply the increased flow rate by the decreased cycle time, what we actually find is they're most efficient, i.e. they use the least water at about 8 to 10 bar. And they're also going to have more effective cleaning because they're going to have more powerful jets. Really, we want to get between 8 and 10 bar fluid pressure at the required flow rates on site. This often involves the installation of a booster pump to get our pressure up there for optimal pressure working. The fourth design factor is multiple tank cleaners. So when we have larger tanks, what we tend to do is we'll divide them into smaller virtual tank sections. Now, each section will be treated as being cleaned by its own StormBlaster, by its own rotary jet cleaner. We ensure that each part of each virtual tank is within range of the jets and conforms to the other design protocols. Now, there's no actual tank modifications. We're not actually dividing the tank into virtual tanks. It's purely on the drawings, we'll box it off. So no tank modifications are made. The tank rotary jet cleaner jets from one section will overspill into another one, but that's okay. They just give a bit of extra cleaning into its tangential virtual tanks. And so as long as each virtual tank can be cleaned effectively according to the protocols by its StormBlaster, any cleaning that does occur into the adjacent tanks is just bonus cleaning. Also, when we install multiple tank cleaners, we tend to run them in sequence rather than at the same time. So this is to reduce the pump duty. So if we had, say, 4 StormBlasters in a big tank, we just run them in sequence. Each would only need the flow rate and pressure for each one of them. If we ran them all at the same time, obviously they need 4 times that and they need a bigger pump. There's no need to run them all at the same time. We'll just run them in sequence, generally from the top of the gradient of the tank down to the bottom, and that will give an effective clean, so we can reduce the pump duty there. Now, as a very rough rule of thumb, you're going to need about 1 StormBlaster per 120 meters squared of tank floor, roughly. There's some complications in that, but that's roughly what you're going to need. And finally, what we need to consider when designing these systems is positioning and access. So as noted, ideally we want to have the tank cleaners on the central line of the tank. This means more of the tank, or the virtual tank, is within range of that effective cleaning jet length, which means you can use less tank cleaners in there. This gives optimal usage of those cleaning jets on the central line. Now, this may not be possible in open tanks that are quite wide. On roof tanks, we can just position the tank cleaner through the roof and it can be removed for access via a manhole cover, so we can get that ideal central positioning. On open tanks, it may not be possible. What we'll tend to do is position them on swing arms. The tank cleaner can be moved back to the side of the tank so it can be removed for maintenance. But the practical length of those swing arms is about 2 to 3 meters. So if we've got a tank above, say, 6 meters in width, then we're not going to be able to position it on that central line. That's okay, it's fine. It just means it's not quite optimal and we may need to modify the design slightly. And that's probably the most common, especially on open tanks. It's not possible to get them in the ideal optimal position all of the time. And to be honest, that's most of the installations that we do. Those are some design considerations that we've developed over the 8 or so years that we've been deploying these systems. We developed this design protocol and we've got about 130 or so of these StormBlaster systems out there cleaning stormwater attenuation tanks effectively all over the UK, France and Ireland.